Hi, in this video we're going to look at how to work out the answer to question 7, which is for the Core 2 Practice Paper 1 paper. I've made this paper for AQA, but it's suitable for other exam boards as well. And as ever, you can get in touch with me on Twitter if you have any questions. So this question is all about the trapezium rule. It says use the trapezium rule with 5 ordinates to find an approximate value to this. And part B, state how you could find a better approximation to the value of the integral using the trapezium rule. Okay, let's make a start then on the first one. The trapezium rule is given to you in the formula booklet. It looks like this. It's the integral between a and b of y dx is approximately given as a half h y naught plus y n plus 2 lots of y1 plus y2 plus all the way up to yn minus 1. Okay, and it also says that h is b minus a over n. But what it doesn't tell you is what n is. So the thing that you have to know is that n is the number of strips. Okay, so it's the number of strips. It's not the number of ordinates, but the number of strips. Now what I would encourage you to do is draw yourself a little picture. It doesn't make any difference at all what kind of shape you're doing, because all you're doing is just making sure that you can see clearly how many ordinates you're getting and how many strips that gives. So in this case, we've got 1, 2, 3, 4, 5 ordinates, which gives 1, 2, 3, 4 strips. So in this case, n is going to be 4. So let's carry on working out the rest of h. So h is 4 minus nothing divided by 4. b minus a, remember from our question, we can see that in this case a is 0, b is 4. So 4 minus 0 divided by n, which is the number of strips, 4 of those. So h for us is 1. So our formula is going to end up being a half multiplied by 1 multiplied by, and then we've got all these different values here for y0, yn, and so on and so on and so on. Now we find these by working out what the values are going to be along x. So this first one will be x0, this is x1, x2, x3 and x4, and we take each of those values of x and substitute them in here to get the corresponding y value out. And the neatest way to do this is by using some form of table. It doesn't really matter exactly how it looks, but some sort of table is going to be useful to you. So let's have a look. So we've got x0, x1, x2, x3, x4, 1, 2, 3, 4, 5 ordinates. We've then got these are our x values here. We've then got the corresponding y values that are coming out down here, which are going to be y0, y1, y2, y3 and y4. Okay, so the numbers we're going to be putting in are going to be 0. This last one is 4. So 1, 2, 3, 4. This is the h part. So the width of each strip is 1. This is what we've been finding out. The width of the strip is 1. Okay, so we're going up in ones. So we're going to put the following values in. We're going to put 0, 1, 2, 3 and 4 in. And the only reason we're putting these in is because the widths of our trapezia are 1. Okay, let's substitute the values into our formula then each time, and let's see what the corresponding y values are. Now, if I was putting x here to be 0, then I'd have 2 divided by 1, which is 2. So y0 is 2. Let's see what y1 is. Well, if I substitute 1 into here, then I'm going to get 2 divided by 1 plus 1, which is 2. 2 divided by 2 is 1. Let's see what happens if I put 2 in. Well, then I'm going to get 2 divided by 5, or 2/5, which is 0.4. Let's see what happens if I do the next one. 3 squared is 9, plus 1 is 10, so 2 over 10 is 0.2. And the last one, I've got 2 over 17 at this point. Now 2 over 17 isn't a number that I know, so I'll do it on my calculator. And I'm going to get 0.117647. Okay, so I've given plenty of decimal places there. Now, the next thing that I'm going to do is to use my formula, okay, with these values. I've got some space over here, so I'm going to substitute these values in. I'm going to end up with a half multiplied by 1, which is h, multiplied by, and then I've got the first and last of my y values. So I've got this one, y0, and this one, yn. So I can add those two things together. So I've got 2 point, you could just write them down as being adding, but I'm slightly struggling for space, so it doesn't really matter. I'll do it like this. Okay, plus 2 lots of 1 plus 0.4 plus 0.2, or better still, we could say that's 2 lots of 1.6, which is 3.2. So I've got a half of 2.117647 plus 3.2, which is a half of 5.317647, which is, let's do that on my calculator, so 2.6588. And that's to 4 decimal places. I think that's a reasonable amount of rounding at that point. Now, the next part, it says state how you could find a better approximation to the value of the integral using the trapezium rule. Okay, it's only worth 1 mark. The answer is always going to be the same thing here, and it is use more strips, or you could put ordinates. Okay, all that happens if you do that is that your graph is going to get smaller and smaller and smaller trapezium, which means that the bits that you're approximating at the top of your trapezia are going to get closer and closer and closer to the line. Whereas if you only use 1 or 2 strips, then hopefully you can see that you've got much more not being on the line, if that kind of makes sense. Okay, nice easy one, trapezium rule, formulas given. Just make sure you set out your work nice and neatly and don't round any y values, because you're going to get more and more accurate by not rounding. And in terms of how can you get a better solution, you use more strips. Easy peasy. Okay, hope this has been a useful one for you. If you've got anything that you need to ask, do so. If you're still stuck on trapezium rule, practice more and more questions. They're all very, very similar to each other. Okay, good luck. Bye.